these is limiting. So here's what you got to do. You got to set up two equations. I will label them Roman numeral 1 and Roman numeral 2. We're doing nothing new. It's the same rot we just did. And we're trying to see how much we could theoretically get here. All right? So we got 25 grams of aluminum, right? This is Roman numeral 1 equation. I'm going to the periodic table, and I know that aluminum weighs how much? There you go, 27 grams of aluminum per 1 mole of aluminum. Okay, what's my ratio between aluminum and aluminum bromide? What's that? That's right, 2 to 2. And in 1 mole of aluminum bromide, that's going to weigh 80 times 3 plus 27. Liz, did we get 267 on that one? Yeah? All right, if Liz is behind, I'm going to wait. I'm going to let her catch me. All right, let's examine what we got here. All right. Let me get all the handwritings caught up with me. Is that what you got, Friday crowd? We only got 2 people here from Friday?
Yeah.
David and what's your name?
It's Bobby and
First.
Brittany. That's good though.
But I thought it was David.
It sounds a lot like Bobby.
Bobby and Brittany. I thought it was David. I want to meet with you one day a week, right? Okay, so what do we get? We get 267. Anybody get 267 other than me? Okay, so whenever we multiply all this out, did I leave my calculator back over there? I'll spend more time looking for my calculator. 25 divided by 27 times 2 divided by 2 times 267. Look at here, 247.2 grams of aluminum bromide. All right, we ain't done yet. That's just calculation number 1. Let's do calculation number 2. This time we're starting with what? Bromine. So we're asking, well, what would happen if bromine was the limiting reagent? Okay, so we got 100 grams of Br2, 160 grams of Br2, because 80 and 80 is 160. 1 mole of Br2. All right. This is going to be 3 moles of Br2 to how many moles of aluminum bromide? That's right. And then in 1 mole of aluminum bromide, we've already calculated it, 267 grams of aluminum bromide we go. All right. So 100 divided by 160 times 2 divided by 3 times 267 equals what? That's 111.25. Now, which one do you think would be the limiting reagent? Well, first off, what are your choices? What compounds up here could possibly be the limiting reagent? Aluminum or bromine, right? Because those things over there are called products. So you figure out which one's used up first. You pick the smallest number. Okay? So the smallest number is 111.25. And what does that mean? That means that bromine is the limiting reagent. It will be used up first. So whenever we're done, will there be any bromine left behind? No. 0. Now how much will there be aluminum left behind? Yeah. And we can calculate exactly how much that would be. I mean, the problem doesn't want us to do that, but we can do it. It'd certainly be a reasonable test question. But a limiting reagent means when you're done, it is all gone. All right, yeah, go ahead. All right. So this, what's that now? So this right here is called the theoretical yield. Okay? This is the maximum amount in a perfect, P-E-R-F-E-C-T, perfect world. Now read the problem. What did John Gates really get? What did he actually recover as the chemist? Okay. Now let's just put it there, right? John really got 64.2 grams aluminum bromide. You see, that's the amount he measured as the chemist. That's called the actual yield, right? All right. So actual yield divided by theoretical yield times 100 gives you a percent yield. Okay. So what did John actually get? 64.2. Now is that expected? Look at what he should have got, 111, right? So I would expect that number to be lower. All right. 111.25 times 100. 57.7% yield. That means he's going to throw away 42.3%. Right? Down the drain, hazardous waste management, wherever it is he's putting it. So that's what the question asks for, is what is the percent yield? Okay. Now people ask me, well, what is a good percent yield? And the answer is, there ain't one. Reactions are very finicky. It depends on what type of reaction you're doing. I have seen natural product synthesis, get this one now, at 0.01% yield. Now what does that mean? How much are you throwing away? Yeah, 99.9 some percent is away. All right? And that's one of the reasons, there's a lot of reasons, but when your drug first comes out, they charge so much for it because its chemists have figured out how to make it. We just ain't figured out how to make it efficiently. So when AstraZeneca's flushing 80-90% of what they started with, then of course the pill has to be $14 a piece. All right? Now as it stays on the market and as chemists get better, we find a more they call it an optimized synthesis, better techniques, this number starts going up. Think about it, if you were working for a chemical company and you were producing metric tons a day, even if that number went up to 60, that is tremendous. Do you understand that? Do you know how much money you would be saving if you could save 3% of a $1 million industry? That's a lot of money. All right. I'll take 3% of $1 million per year. All right. So are we good? Let's talk one more thing on percent yield. We'll take us a quick break here. Give me a reason that this number may be higher. Okay? So let's just say John was supposed to get 111.25 grams and he come to me with some cockamamie 120.3 grams. Why would that number be higher? Do you may have any ideas? No one wants to problem solve through this? What's that now?